Welcome to this lecture. So in this lecture we will understand relation. So guys, let's understand relations with the help of this definition. So relation is a linear operation which establishes a relationship between the elements of two sets according to some definite rule of relationship. Alright, let's say for example we have two sets here, set A which has elements 1, 3 and 5 and set B which has elements 1, 5 and 6, right? So a relationship R between A and B will be such that it will relate the elements of the two sets in some way. Alright, that will be the relation. So for example, if we define a relation R which is equal to, alright, here we are defining a relation which is equal to between sets A and B, alright, then that relation is given by equal to means you will take all the elements from A and see which all elements are equals to the elements in B. Alright, so here relation R will have basically two ordered pairs. One is 1, 1 because 1 is equals to 1. This ordered pair from A to B will be a part of relation R. Alright, so we have written 1, 1. Similarly, if you see 5 from A is equal to 5 from B, so another ordered pair in relation will be 5, 5. So a relation R will be defined like this between A and B, and here this element represents the element from A and second one represents the element from set B, because these are ordered pairs in which the order matters. Alright, so you can clearly see relation R between two sets A and B is a subset of A cross B, where A cross B is nothing but the Cartesian product. Alright, A cross B, as we learned in the previous lectures, is a Cartesian product between A and B, and A cross B is different from B cross A. This we learned. Alright, so a relation between sets A and B is a subset of A cross B. As you can see, 1, 1, 5, 5 is actually a subset of A cross B, because when you do A cross B you will have all the ordered pairs from set A and set B. Alright, so you can interpret that it's a subset that contains all the pairs for which the relation is true. It contains all the pairs for which the relation R, which means equal to, is true. Alright, so we write A R B, where it is saying A is related to B if the relation is true for A and B. Alright, or equivalently you can say that A comma B is an element of set R. Like here you can say that 1, 1 is an element of this relation. Alright, makes sense? So relation between any two sets is represented like this. So when I'm saying A R B, I can say that 1 R1, this is true. Right, here relation is equal to, you can clearly see that 1 is equals to 1. This one is from set A, this one is from set B. Alright, and here is an important note that A and B sets which are mentioned here, they can be same also. Alright, so when A and B are same, in that case relation is said to be on rather than between. Like when it was A and B, we said R is a relationship between set A and B, right? But when it is just for one set, it will be on A, which means it will be a relation on set A such that it is a subset of A cross A. Relation on set A means it will be a subset of A cross A. Example is, suppose A is 0, 1, 2 and 3. Then if you have to define a relation equal to, then it will be like a subset of A cross A, where one element will be from A, second element will also be from the set A itself. So you can see that 0 from this set is equals to 0 from this set, 1 from this set is equals to 1 from this set, 2 from this equals to 2 from this, and similarly 3 from this is equals to 3 from set E, because A set is the same set. Alright, so A cross A means one element from A, another element also from A. So equal to means 0, 0. Similarly, if you have to define a relationship on set A which is less than, then what you're trying to say is take an element from this set which is less than the other element. Alright, so the pair is this 0, 1, 0, 2, 0, 3, 1, 2, 1, 3, 2, 3, because 0 is less than 1, 0 is less than 2, 0 is less than 3, 1 is less than 2, 1 is less than 3, and 2 is less than 3. Alright, so this is the relation R which is less than. Similarly, if we define a relation R which is greater than or equals to, then the elements will be all the equal elements, obviously 0, 0, 1, 1, 2, 2, 3, 3. These are all the equal elements, and all the elements which are greater. Alright, so here we will take the element, this one being greater and this one being lesser. Alright, so this will be 1 comma 0 or 2 comma 1 or 2 comma 0, 3 comma 2, 3 comma 1, 3 comma 0. Make sure that 0 comma 3 will not be part of this relation, which is the third relation, because greater than equal to means we are saying that the first element or the first element out of this ordered pair, that should be greater than the second element. Alright, but here the first element is lesser. 0 comma 3 will not be part of this relation, but 3 comma 0 will be. Alright guys, makes sense? Alright, now here is the question in front of us. We are given that A is a set which has 5 elements and B is a set which has 2 elements, and we are given a relation that R is a relation from A to B, which is defined by that R will contain all the ordered pairs A comma B such that A is a element of A, B is a element of B, which is clear. But the important one is A is divisible by B. Alright, we have to choose all those ordered pairs between A and B such that the element A should be divisible by the element of set B, and we have to write that in roster form. So we can say that we have to choose all the ordered pairs. So I will write everything which comes from set A in red color and everything which comes from set B by black color. Alright, so let's say 2. Alright, so 2 is the element from A, and we can see that there is corresponding element in set B which divides this 2. So we can see that 2 comma 2, because this 2, which is the element from set B, it divides this 2 which is element of set A. So this makes an ordered pair. Alright, second, we can see that 4 is also divisible by 2, so we can write 4 here comma 2, because 4 is the element of A and it is divisible by 2, which is the element of B. Similarly, we can see 5 is an element of A which is not divisible by any element of B, so we cannot choose that. 6, now if we see 6, we can see that 6 is divisible by 2 as well as by 3, so we can make 2 pairs here, 6 comma 2 and 6 comma 3. Alright, makes sense? This is how we define a relation between any two sets. Alright, makes sense?